All right, folks, so here is a recap on today's lesson. This is part 2 of 8.1 having to do with accumulation and net change. And this is actually a very easy concept that takes what we already learned and just applies that foundation to different contexts, okay? These kind of questions you're going to learn today are going to be all over the multiple choice, but they're not going to get too crazy with the difficulty and what they ask in the multiple choice, but they do increase the difficulty when they get to the FRQs. And usually they're in question number 1 or 2 in the FRQs. Okay? Now, yesterday and the day before, we said that the area, which is velocity multiplied by time, is equal to the distance distance and position, which is S of t. So another way of thinking of saying that is the integral, which is the area bounded between the v of t curve here and the x-axis, is going to give us the position function and distances. Now, we're going to apply that to different contexts, okay? I'm going to do a play on words and say, instead of velocity, I'm just going to say rate, okay? And we said that equals to the amount of distance, so to speak, so far. Now I'm going to say the integral of rate is the amount of something. So in this case, if we have the rate, if v of t is the rate of snow falling, then if you do the integral of that rate of snow falling, you're going to get the amount of snow that fell. Also, if you say the integral, the v of t is the rate of pizza temperature that cools, okay? All right, so for example, it cools by, I'm going to make something up, by 2 degrees Fahrenheit per minute, okay? I just made that up. Then if you integrate that rate, then you will get the amount that the pizza cooled by. Okay, so whereas we did specifically up until now, we did the integral of rate, the integral of velocity is equal to the amount of distance. We're applying that same concept to different contexts now. So we're long story short, we're right. The summary of today's slides is when you integrate the rate of whatever, you get amount of that whatever. Okay, so let's go ahead and look at this problem over here. Okay, you can pause it and read it for yourself, but basically we have a velocity function, and it asks us for the distance. So this is actually the same exact context that we did thus far. So we're basically going to integrate this velocity function for the time, okay, this velocity function for the time of 0 to 14 minutes, okay? And because it's asking for distance, we're going to do the absolute value, okay? And so the way you do it on your calculator, okay, you can go a couple ways, but let's just do it this way. 4 times pi times sine of pi x over 5, okay? And then quit that. Math option 9 for integral, 0, 14, you can manually enter the green, but since we have it in y sub 1, let's first of all recall, let's call upon the absolute value function. Okay, boom, boom, and let's insert y sub, I meant to say alpha, okay, and put y sub 1, so alpha trace, and let's put dx here, all right. And we should get 116.18 over here. Okay, it's just waiting. Calculator's loading. Okay, let's see. I don't know why it's taking so long, but there you go. So 116.18. Okay, so let's go to the next slide over here. The next slide, it's the same foundation applied to a different context, like I said multiple times already. Now the context is water decreasing at a rate. So we have the rate, which is related to the velocity function. So we're going to insert that rate, okay, this into this right here. And then we have 5 minutes, so 0 to 5. And then you literally just put this in your calculator like I showed you earlier, okay? Make sure your calculator is in radian mode, and make sure when you enter it in your calculator, put this in parentheses, the 4t plus 3. Okay, look at these parentheses around the 4t plus 3. Okay, because if you don't do that, it's going to add the 3 after dividing. It's going to do pi over 4x, calculate that, and then plus 3, when what you really want to do is pi over, in parentheses, 4x plus 3, hence this. Okay, over here, the concept is really easy. Now we're just using geometric shapes to calculate the area. Okay, so here it's just a simple scenario where you're not given the actual function, but you're given some easy geometric shapes to subdivide visually the function into. Okay, so we use this dividing line right here and add the trapezoid over here, the area of the trapezoid, plus the area of the rectangle. Remember, area of trapezoid is base 1 plus base 2, okay? Base 1 plus base 2 multiplied by your height and then multiplied by a half, okay? Last one over here, okay? We have a rate function, okay? Right here from 0 to 6 hours, boom, boom, boom. And then we also have the starting, the starting amount. So you add it, whoops, I highlighted the wrong thing. The starting amount, which is here, so you just add the starting amount with this area over here, with this right here, all right, and you get 15.48. And remember, this will represent the amount of gallons that it changed by, and you add it with the first amount, and you get 15.48, okay? So there you have it, folks. That's today's lesson, okay? Thank you for tuning in.